Let's get started with the first topic on homework number 31, which is solving a system of inequalities by looking for a single ordered pair or point that satisfies both inequalities. You can solve this algebraically or graphically. So graphically, you'd be using the inequality app on your TI-84. If you have an older version, you'll see it pop up down here as long as you turn the app on by choosing the function. And then once you're in the y equals menu, if you put the cursor on top of the equal sign, the inequalities will appear. You have to use the green buttons F1, F2, F3, F4, F5 to activate these symbols. So if I wanted to graph the first one, y is greater than negative 4x plus 4, I would choose the alpha key and the greater than button, which is F4. So y is greater than negative 4x plus 4. And then I would arrow down, again, over to the equal sign, and I would type the alpha F2 button for the less than, and then type negative 2x plus 8. If you have a newer model calculator, then after you turn your app on, which is typically number 7, after you turn that app on, and you go to your y equals menu, when you arrow over here, turn that app on. Oh, yes, I did. When you arrow over here and press enter, you can see the second option down is where you'll change the symbol. So you press the left or right arrows to change from less than to greater than. So let's see, we had greater than negative 4x plus 4. So I would arrow over again, greater than, and then I would click OK. The 4x plus 4, whoops. For the second one, when I arrow over all the way and press enter, I'm going to choose less than sign. So I arrow down, click to my less than sign, oops. Click OK, then type in my function, negative 2x plus 8, I can take a look at my graph here, and I know that anything in this solution area, that's what we call this, some of you call it the double shaded region, anything in this solution area would be a solution. So I'm looking for 3, negative 7, so I'm over here 1, 2, 3, negative 1, 2, 3, 4, 5, 6, 7. So it looks to be right about here. Seems like that's a solution, but let's double check the rest. Negative 10, negative 3. Well, negative 10, negative 3 is way over here, so no. 2, negative 3. Here's 2. 1, 2, 3. I'm not really sure. It might be on this boundary line. And then 8, negative 10. So 8, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 7, 9, 10. Let's go back and read this question. Which point would not be a solution? So I found 3 that were, but it looks like negative 10, negative 10, negative 3 was the only one that would not. And if I wanted to double check that algebraically, I simply would substitute these two values into their appropriate letters. So x is negative 10, and y is negative 3. And we would check that math. Is negative 3 greater than 40 plus 4? And as soon as it fails one inequality, you don't even need to check the other. As soon as this is a no, the whole system is a no. So you can check graphically or you can check algebraically. Again, you can type this in your y equals button and take a look. Again, they're looking for something that would not be a solution, or you can put all of these values into x and y and check algebraically. The second one is asking you to actually graph the system yourself by choosing what type of boundary line, choosing what type of shading. So you could certainly check on your graphing calculator to make sure that your final answer matches. So I'm going to start with greater than or equal to 5/4 x minus 8. So minus 8 is my y-intercept. I'm going to rise 5 and run positive 4. And now I'm going to keep the line solid, but I'm going to change the shading to above. The second one has a y-intercept of -1. It has a slope of -1/2. Now I can only use that negative sign once. So I'm going to go down, and I'm going to go right 2. I'm going to change my line to be dotted. And I'm going to change my shading to be below. So I had to click this twice. And now the question is, state the coordinates of a point in the solution set, which is in this darker shaded area here. So I'm just going to choose any random point, but nothing along this dotted line. Definitely not the intersection. But I could choose this black dot if I wanted, but I'm just going to be safe and go right over here at -6, -5. Again, you graph by first using the y-intercept, then clicking the point by moving the slope, which is -2, +1, changing your line if necessary, changing your shading if you need to. Graph the y-intercept of 7. This has a slope of +1, +5. This has a solid line, and this has shading below, and choosing any random point in this solution area here. This one is something that comes up every so often. A two-way table is data which you can read this way, you can read that way, and that's why it's called a two-way table. They're asking for what percent of people between ages 21 and 34, so that means we can only concentrate on these people. There's 34 of them, and that total was given to us. So we can only use those people as our whole. And then we want to know what percent prefer football. So we want this number, football, over this total value of 34, and they're asking us what percent is that. So when you have a proportion, which is what this is, you can state that the cross products are equal. So 34x is equal to 700, and then you divide 700 by 34, and you round your answer to the nearest whole number. So I'm going to do 700 divided by 34. I'm going to say 21. That's going to round up to 21. So I'm going to type that here, 21%. And that's it. Again, make sure you're using the correct total values. Depending on the question. So this one here says what percent of 8th graders, so that means we can only use this value. What percent of 8th graders estimated they spend less than an hour a day on social media? So that's 25 out of 55. And that is how we are reading this two-way table. The next one is visual domains, and you can use either interval notation, that's these symbols down here, or you can use inequality notation, that's these symbols here, but note that they should always start by pointing this way. You can have two less thans, you can have two less thans or equal to, you can have one of each, right? But they always point in this direction when you begin. So I'm going to do the first one with interval notation, and it's asking for the domain, so be a careful reader. The domain is your x values. So how far does it stretch to the left? How far does it stretch to the right? And those are the numbers we're looking for. So it looks like it stretches as far as -3, and it is solid. And it looks like it stretches as far as +5, and it is solid. So you could write your solution like that, or, since it's domain, you put an x in the middle. And since they're both solid, we put equal to signs. You put your lowest number on the left and your highest number on the right. So -3 to 5. I'm going to type that here. And we'll try one more. Let's see what we get this time. We get another domain. So again, if we're writing inequalities, that means we start with an x. So when we talk about domain, it always starts with an x and two less than signs. It goes as far left as -2 and it's solid. It goes as far right as +9, but it is open. So we can use a bracket and a parentheses. So -2 to 9. We'll type that down here. -2, this time I'll use the inequality notation with the x in the middle. Let's see if we can get a range question. Here we go. Determine the range. So the range always starts with a y in between the two less than signs. And it talks about how high up you go on the y-axis and how low down you go on the y-axis. Now this generally does not use these solid points in its values. So as you can see, it's a solid line, so that means it is equal to, because the line is completely solid. It goes as low as -1 and as high as +4. As low as -1, as high as +4. Okay, and that's how you complete the domain and range. In this question here, we're going to get it in standard form first by subtracting 3 from both sides. And that's going to give us a difference of 2 squares. Don't forget, whenever you're factoring, you always go in this order, always looking for a GCF, then a difference of 2 squares, and then a trinomial. A difference of 2 squares has no middle term, and that's because you had an original sum and difference. We square root the first, we square root the last, and then we separate our two factors into their own two separate equations. Getting ahead of myself here. And then we solve. This one is -6, this one is +6, and when you type those answers in here to Delta Math, as soon as you type the comma, it will open up those braces for you. Alright, this one looks like it might start as a trinomial here, so I'm going to take a look. Screenshot it. Let's see. I'm going to add 6x to both sides. I'm going to add 5 to both sides. That's going to give me x squared plus 6x and minus 27. Okay, so there's no GCF. This is definitely not a difference of 2 squares. So it looks like I'm onto my trinomial diamond pattern. So I need something that multiplies to -27, but adds to 6. -27, I'm going to get 9 and -3. Since there was nothing in the A position, I don't need to slide divide, so this is x minus 3, x plus 9. Those are my factors. These are my separate equations. And my final solutions are 3 and -9 in braces. We generally put the lower number first, but it doesn't matter. So 3, -9, and we submit. Alright, next topic, solving quadratics with square roots. So let me take a quick screenshot of this and show you what we're talking about here. Alright, so once we kind of manipulate this here by subtracting 31 from both sides, we're going to get 50, 60. We're going to get this. And so what we want to do is we want to start solving this, but try and keep this intact. Don't FOIL it out, don't distribute. I want to keep it intact because I know that I can square root that eventually. So first thing I'm going to do is equally use my division property of equality. And technically, this is what I'm doing. So let me write that properly. So here I'm going to get quantity x minus 7 squared minus 30 equals 0. And now I'm going to actually add 30. Oh, I guess I should have initially brought the 29 this way, but that's okay. Quantity x minus 7 squared equals positive 30. This is good. And now let's see. Now I'm going to square root both sides. Now be careful when you square root both sides here. We know that the square and the square root cancel out. But be careful over here on the right. When you square root a value, you're going to get a plus or minus answer. And then the square root value. So I could try and simplify this, but I don't think I have any perfect square factors. So the only perfect squares less than 30 are these, 5, 4, 3, 2, 1. Yeah, none of these perfect squares divide evenly into 30, so it looks like I just have to isolate my x, and I'm done. But notice I have a plus or minus sign in front of that 30. So 7 plus or minus the square root of 30. 7 plus or minus. I know that because it says simplest form. It doesn't say to round. So I'm going to write a 7. I'm going to click this plus or minus sign and the square root of 30. Let's try another one like this. I think this time, instead of bringing the c value to the left, I'm actually going to bring the c value to the right. So I'm just going to start off by moving this 8 over here. And I'll keep this quantity the same. And I'll get a 24. And now I'm going to use my division property of equality. Oops, sorry. There we go. And now I can square root. And don't forget, when you square root a value on the right side, you get 2 answers. The square root of 6 cannot be simplified, so I'm simply going to subtract 9 from both sides, and my final answer will be negative 9 plus or minus the square root of 6. Negative 9 plus or minus the square root of 6. All right. I think that's enough of the square roots. I gave you 3 to practice there. And now we're going to start something new here that we're learning this week, which is transformations of functions. So x squared, which is our parent function here, it's our parent function, is this black parabola here. That is the parent function, and we want to shift it. And it looks like the vertex moves 2 to the right, and it looks like it moves 4 down. So 2 right and 4 down. Now if you remember anything from class, the left and right shifts happen inside the parentheses, and the up and down shifts happen outside of the parentheses. Now the up and down shifts are intuitive, meaning their signs match their directions. So if you're going up, it would be plus 4. If you're going down, it would be minus 4. So I know that right here needs to have a minus 4. So I'm going to click there and I'm going to write negative 4. And then I know that this value here is a shift left or right. But it's actually counterintuitive. I know typically when we move to the left, we think it's negative. But in this transformation function, moves to the left, right? See, I'm trying to be creative here. Moves to the left, have a plus sign, and moves to the right, have a minus sign. So moves to the left have a plus sign. So if I am moving to the right, I need a minus sign here. So 2 spaces right would be minus 2, and once I click away, this shift will happen, and now I can click submit. Let's try another one. Again, this vertex, which is what you should be concentrating on, this vertex here is moving to the left and moving down. It's moving left and down. So left is in the parentheses and down is outside the parentheses. So left is plus and down is minus. So it looks like I'm going to move left 4, so that's plus 4. I don't even need it. And I'm going to move down 5. So I need a minus 5 here. And once I click out, it will transform and I can click submit. Now we're going to complete the square by finding the constant that we need. And this is something new that we've been learning. So completing the square is when you deliberately try and make your sentence factorable. So here's my sentence, x squared plus 15x plus 7. And what I want to do is I want to take this 7 and I want to move it to the other side. And by doing that, I create a space for myself of something that I can place in here that will make this a perfect square factor. That's what I'm looking for. Something that has factors that match. And I know that because this middle sign is positive, that the sign in the middle of my factor here will be positive. So to do this correctly, you have to take half of this number. And for us, it's odd, which is a hard one, but we have to take half of this number and square it. So we want half of 15. So I'm just going to write 15 over 2, and I'm going to square it. And so typically we want you to keep it in fraction form. We really don't want it in decimal form. So when I square this, I'm going to get 15 squared over 2 squared, and that's what I'm going to add to both sides. 225 over 4. So 225 over 4. All right, next one, we're going to do the same thing. We're going to complete the square. So for us, this is the middle term. Whoa. The middle term is -3, and so we are going to take half of that, and we're going to square it. That gives us 9 over 4, so all I need to do is type 9 over 4. And then for the next one, they actually want you to solve it. Okay, when we solve by completing the square, the first thing we need to do is move this value over, because eventually that will be part of our solution. So we're going to get x squared plus 10x, big space, and -24. Now again, you complete the square by doing half of b and squaring it. That's the magic number that's going to go here and here, because you have to be fair, right? So if we're going to add it to the left, we need to add it to the right. So half of b is 5, and 5 squared is positive 25. So I'm adding 25 to both sides. The reason why I'm doing that is because I know that the diamond pattern factors here will always be a match. The diamond pattern factors will always be a match. Now you can certainly go through the process of doing the diamond pattern, but when you go to factor it, it will always be the same sign and whatever half of b is. That's going to be your factor. So you can go through the whole process of using the diamond pattern, but the shortcut is that it's always going to be half of b. Now be careful with the math over here. Make sure you perform it accurately. The answer will be 1. Now I'm going to solve this by square rooting, which is the whole point of completing the square. To solve your quadratic by square rooting. Now don't forget, when you square root the number, you get 2 answers. So don't forget. So x plus 5 is equal to 1. And if I subtract 5 from both sides, right, if I subtract 5 from both sides, then technically I get -5 plus 1 or -5 minus 1. So I need to answer both of those questions. -5 plus 1, right? Negative 5 plus 1 is negative 4, and negative 5 minus 1 is negative 6. So my two answers are negative 4, negative 6, and I solved it by completing the square. Once you type a comma, it will open the second value. Let's try this again. Remember, the whole point of completing the square is to get something that is factored into a repeat factor. So we already have, we already have our C value on the other side. So what I'm going to do here is just create a space where I can actually show that I'm completing the square. Don't forget, it is half of B squared is the value you put on each side. So half of 16 is 8. 8 squared is 64. That's what I'm adding on both sides here. The reason I did that is because I know the diamond pattern here is going to be the same sign, and half of B. So there we go. When I square root both sides, I cancel the square, but I get two answers on the right. Now this happens to be the same number as before, and now I'm going to subtract 8 from both sides, in which case I'm going to get two possible answers. Negative 8 plus 1 or negative 8 minus 1, and I should compute that because I can. So this is going to be negative 7, this is going to be negative 9. So negative 7 and negative 9 are my answers. Try one more. This one here is a little jumbled up. I need this 80 to move to the right, but I need this 18x to move to the left, and it would give me this giant space. Okay, so now I need half of 18, and then I square it. That's how I'm going to complete the square. So half of 18 is 9, 9 squared is 81. Oh, they keep giving us this one value, which is really nice and easy to square root, so that's pretty friendly. Don't forget, the whole point of completing the square is to have two repeat factors. And the sign from the middle here stays your sign from the middle there. And then I want half of B, which is my factor. So now I'm going to square root both sides. I'm going to get my two answers on the right and my binomial on the left. And now now all I have to do is add 9 to both sides and perform that math. 9 plus 1 and 9 minus 1, which is 8. So 10 and 8 are my solutions here. All right. Completing the square. This one's not asking you to solve it. It's just asking you to state which one has the same value. So the first thing you'd want to do here is move that constant 20 to the other side. First thing I want to do is move this 20 to the other side. That will leave me with x squared minus 14x, giant space, and I was subtracting 20. So negative 20 plus 3 is negative 17. Now I'm going to complete the square, which is finding half of b, 7, and squaring it. So I'm actually going to be adding 49 to both sides. And when I do that, over here, I'm going to get a 32. So I already know that this and this cannot be right. So all I need to consider is what should be the sign in the middle. And don't forget, the sign in the middle of your factor always matches the sign in the middle of your original trinomial. So that means I'm going to choose the minus. So again, move your constant to the right. So I'm going to take this plus 5 and I'm going to subtract it. And that's going to leave me with x squared plus 16x, x squared plus 16x equals 4. Now, before I even go any further, what sign is going to be in the middle of my answer? A plus sign. So I can start crossing things off. Now all I really need to determine, since these are a match, is what will the new c value be. So half of 16 is 8. 8 squared is 64. So when I add 64 to both sides, I get 68. And so now I know why this one is the answer. And that concludes homework number 31.